Nanocenter is a joint project of several Slovenian research institutions and technology companies. The center provides facilities and state-of-the-art equipment in the field of nanotechnology. One of the latest research results, where Nanocenter's equipment was involved in, is the discovery of interesting phenomena in the crystal of tantalum disulfide.
After exposure of the crystal to a single femtosecond laser pulse, we observed a large change of resistance and a very easily detectable change in the optical reflectivity. We immediately recognized the application potential of such a switching device. In order to make such a device, we decided to use laser lithography.
Laser lithography is performed with the protolaser LDI device. The device represents the result of cooperation with industry, which is one of Nanocenter's main goals. Tantalum disulfide is a layered crystal that can be easily cleaved using Scotch tape. Thinner flakes can be obtained in several cleaving steps. The tiny pieces can be transferred to the sapphire substrate just by firmly pressing the tape to the substrate. The result of the deposition is checked under a microscope. The surface of the substrate is inspected for appropriate candidates to pattern the electrodes on them. For this purpose, a photoresist is spin-coated on the crystal. By spin coating, thin film of the selected thickness is obtained, which is eventually fixed and dried by baking it briefly. The main step in the preparation of a sample is the patterning with the laser lithography system. The sample on the substrate is easily inserted into the system. No evacuation is needed. The work can start immediately. The advantage of the protolaser LDI is the ability of leveling the sample. The tilt of the sample can be corrected, which enables precise structuring on irregular objects, such as this crystal. The position and shape of a targeted crystal is marked. The pattern doesn't have to be designed in advance, but can be drawn on the spot. Electrodes are easily outlined using drawing tools or simply imported from another CAD software. With drawing and working parameters such as laser beam diameter and exposure dose, the pattern is defined and transmitted to the device. Custom patterning is enabled by deflecting the beam with a sub-nanometer resolution over the crystal surface. Another advantage of the protolaser LDI is writing speed. The pattern is exposed in a sequence of laser pulses, dot by dot, with the speed of 100 kHz. Areas of a few square millimeters can be exposed within a few minutes. After exposure, the pattern is developed in the developer and inspected under a microscope. Then, the surface of the sample is metallized and liftoff is performed. At the end, the final outcome are tiny golden electrodes on the sample that can connect the sample with a measuring system.
Tantalum disulfide is an exceptional electronic material exhibiting a number of different collectively ordered states at different temperatures. By using an ultra-fast laser pulse, we're able to switch to and from a new hidden state which is not thermodynamically accessible. The hidden state is topologically protected, which explains its remarkable stability.
We presented just one example of the use of Nanocenter's equipment for laser lithography. Protolaser LDI can be used for all kinds of two-dimensional microstructuring on a conductive or non-conductive substrate, from microfluidics, mask prototyping, even fabrication of simple micro-objects.